Good morning children, welcome to GCC Education online class. Today we will start with a new topic, capacitor. So capacitor அப்படிங்கும்போது it's a device which is used to store electric charges or electrical energy. So capacitorல எப்படி description கொடுக்கணும் அந்த apparatus ஓட description அதில் என்ன இருக்கும் அப்படின்றது it consists of two conducting plates. Like இப்படி ஒரு plate இருக்கும், இப்படி ஒரு plate இருக்கும், parallel plates இருக்கும். Let us name this plate as A and this plate as B. So capacitor is a device which is used to store electrical energy, electric charges. It consists of two conducting plates, plate A and plate B I have drawn on the board. These two conducting plates are connected to the two ends of a battery. The battery potential of the battery, the voltage of the battery is V, let us suppose. The positive end of the battery is connected to the plate A and the negative end of the battery is connected to B, the plate B. Once the plates are connected to the battery terminals, what will happen? I told you these two are conducting metal plates, conductors. அப்படி இருக்கும்போது conductors will have free electrons. So what will happen? Let us suppose the electron from this is the A is connected to the positive end of the battery. So one electron will flow from A to B. So A will lose one electron, it will become positive. B will gain one electron, it will become negative. This process will continue. Electrons will be continuously transferred from the plate A to the plate B. So this work is done by the external battery. The battery is doing the work of transferring the electrons from the plate A to the plate B. So plate A will acquire more positive charges as more number of electrons are transferred from plate A to plate B, and plate B will acquire negative charge. So plate A acquires, let us suppose plate A acquires positive charge plus Q. Plate B will acquire negative charge minus Q. So the magnitude of the charge will be the same, but A will acquire positive charge and B will acquire negative charge. So how long this process will take place? So once the plate A acquires a positive charge and plate B acquires a negative charge, a potential is developed between the plates. Between the plates a potential is developed, and this potential we call as a plate potential. This is the battery potential. So how long this transfer of electrons will take place from A to B means until the potential between the two plates A and B becomes equal to the battery potential. Just for example, suppose if this is 6 volts, we are applying 6 volts external battery, then this transfer of electrons will continue until the potential between the plates becomes equal to the 6 volts. So after which this transfer will be stopped and energy will be stored, and electrical energy will be stored in the plate A and plate B. So this is the principle how the capacitor works. So supposing if we want to store more number of charges, then we have to increase the external potential. Supposing if I increase external potential, the battery potential from 6 volts to 8 volts, just for example I am telling, then what will happen? More number of electrons will again be transferred from plate A to plate B until this plate potential becomes equal to 8 volts. So what do we understand from this is the amount of charge Q acquired by the plate in the capacitor depends directly on the battery potential. So Q is proportional to the potential which is applied. So we can frame an equation. Q, the charge of the capacitor, Q which is the charge acquired by the capacitor, is proportional to the voltage. Means Q is equal to, if we write it in an equation form, then we have to introduce a constant. So Q is equal to CV. This constant C is called as capacitance of the capacitor. So Q is equal to CV means C is equal to Q by V. Just rearranging this equation, we get the formula for capacitance of the capacitor as C is equal to Q by V. From this formula itself, you can define the capacitance of a capacitor. Just to see what is this Q? It is the magnitude of the charge that is stored in the capacitor. And what is this V? V is the potential that is applied. So how will you define the capacitance of a capacitor? It is defined as the ratio between the magnitude of the electric charge in either of the plates and the potential difference between the plates. So this is the definition for capacitance. Let me just read it out once again. Capacitance of a capacitor is defined as the ratio between the magnitude of electric charge in either of the plates and the potential difference between the plates. So once we have defined capacitance, we have got an equation for the capacitance. The next step is to write the SI unit of capacitance. SI unit of capacitance, from the formula itself we can write the unit of capacitance, because we know the formula for capacitance. C is equal to Q by V. Unit of Q, charge is coulomb. Unit of potential, that is voltage, V is volt. So the unit of C is coulomb by volt. Symbol we can write as C per V. So normally this is the unit, actually SI unit, but normally we never write the unit of capacitance as C per V. This 1 C coulomb per volt is equivalent to, taken as equivalent to farad, which is named, the unit is named, unit of capacitance is named after the name of a scientist, famous scientist Michael Faraday. So the unit is named after the scientist Michael Faraday. So you have to remember the SI unit of capacitance is farad. Capital F is the symbol. When you write it in full form, F-A-R-A-D, farad. So but normally the value of capacitance will not be equal, will not be very high in farads, but it will be having very smaller units of farads. So we have already learnt about larger units and smaller units in our 11th standard. So smaller units of farad means in the order of microfarad and picofarad. So normally capacitance will be, practical units of capacitance will be in the order of microfarad and picofarad, very smaller units of farad. Microfarad, 1 micro we all know it is 10 power minus 6 farad. Picofarad, 1 pico means 10 power minus 12 farad. So SI unit of capacitance means you can write farad. What are the practical units of capacitance means you have to mention only these two units, microfarad and picofarad. Micro means 10 power minus 6 farad and pico means 10 power minus 12 farad. Now normally in physics, this capacitance it is a device that will be used in so many circuits. So while mentioning this, normally battery, we have the symbol for battery, for resistor, everything like that. What is the symbol for this capacitance? The symbol for the capacitance is, you have to draw two, because we all know capacitance consists of two parallel plates. So we have to draw two lines, parallel lines, both must be of same length. You have to be very careful, because when you draw one line, bigger line and smaller line, it will indicate a battery. So for indicating the symbol of capacitor, you have to draw two equal lines, length of equal lengths like this. This is also the another method of drawing the symbol. One can be a straight line, one can be curved like this. This is also correct, but normally we use only this general symbol for, this is the general symbol normally we use for capacitance. So now what is the total charge that is stored in a capacitor? Because as we all know, capacitor it has got two parallel plates, plate A and plate B, and when we connect an external battery, electrons will be transferred from one plate to another plate, so that one plate will appear positive charge, another plate will appear negative charge, equal in magnitude but opposite in direction. So one plate will appear plus Q, another plate will appear minus Q. So if we ask about the total charge that is stored in a capacitor, now what will we tell? Plus Q and minus Q, it is 0. So normally when what is the charge? Normally what is, if somebody asks what is the amount of charge that is stored in a capacitor, we only mention the charge that is stored in either of the plate, any one of the plate. So that is normally plus Q. What is the amount of charge that is stored in the capacitor? We should not take the total, but we should mention it only as plus Q, coulomb, right? So now we will derive the expression for capacitance of a parallel plate capacitor. So we all know capacitor consists of two parallel conducting plates, plate A and plate B. and it is connected to an external battery. Once we connect the external battery, we all know electrons will get transferred from one plate to other plate. A will acquire positive charge and B will acquire negative charge. So, total charge that is stored in the capacitor, now I have already told you, we have to mention only the charge that is stored in any one of the plate. So, total charge stored is Q. The area of the plate which we take, let us assume the area of the plate as capital A. Now, the distance between the two plates, we take it as small d. So, once we know the total charge and area, we can write the surface charge density. That means charge per unit area. Charge per unit area, which we have already learnt in the first part, initial part of our lesson, which is sigma. Surface charge density is denoted by the letter sigma. Sigma is charge per unit area, that is charge by area, that is sigma is equal to Q by A. This you name it as equation 1. Now, we are going to find the capacitance of a parallel plate capacitor, that is C is equal to Q by V. For that, we need to recollect the expression what we derived in Gauss law. Using Gauss law, we derived the expression for the electric field at any point between the two parallel plates. So, we derived for 3 different positions, that is one in between the 2 points, then outside the point on the right, both on the right hand side and the left hand side. But now here we are going to use only the expression which we derived using Gauss law. We derived the expression for the electric field at any point in between the 2 plates. Hope you all remember the expression. The electric field E at any point between the plates, E is equal to, I have taken only the magnitude, E is equal to sigma by epsilon naught. So, here take this as equation 2, substitute this equation 1 in equation 2. Already we have written for surface charge density sigma is equal to Q by A. So, substitute for sigma as Q by A. So, you substituting 1 in 2, you get electric field E is equal to, instead of sigma you substitute Q by A. So, you will get the equation E is equal to Q by A epsilon naught. Now, we know the another definition for electric field, that is the relation between electric field and electric potential. We have already mentioned in the previous part of the lesson. Electric field is defined as the negative gradient of electric potential, that is E is equal to minus dV by dr. Gradient means with respect to distance, we all know that. So, E is equal to minus dV by dr. Here dV is nothing but the potential, dr is nothing but the distance. Here we can take the distance between the 2 plates. So, this equation can be written, in this case we can write E as E is equal to V by d. So, from which we get V is equal to ED. Keep V in this side, denominator D if you take it to this side, it will go in multiplication. So, V is equal to ED. So, this expression you mention it as equation 4. Now, we have got the expression V is equal to ED. Already we have derived equation 3, I have written here once again. Electric field E is equal to sigma by epsilon naught. For sigma we substituted as Q by A. So, E is equal to Q by A epsilon naught. So, this E you have to substitute here. So, V is equal to, for E you substitute Q by A epsilon naught. So, E Q by A epsilon naught, D you write as such. So, you will have V is equal to QD by A epsilon naught. All over children. Now, we will finally derive the expression for the capacitance of the parallel plate capacitor using the general expression what we defined in the morning. C is equal to Q by V. So, take this as equation 6, this is equation 5. Now, we have to substitute this V, that is equation 5 must be substituted in equation 6. So, you will have C is equal to Q, write as such. For V you substitute QD by A epsilon naught. This Q will get cancelled and this you can take it to the numerator, epsilon naught A by D. So, this is the final expression for capacitance of a parallel plate capacitor. C is equal to epsilon naught A by D. Now, we are going to interpret this expression what we have got. We have to discuss the conclusion. That is, conclusion is, what do we understand from this expression? The capacitance of a parallel plate capacitor depends on 2 factors, because epsilon naught is a constant. A, the area of the plate can be changed, and the D, the distance between the plates also can be changed. So, capacitance depends on both A and D. But capacitance is directly proportional to the area of the plate and it is inversely proportional to the distance between the plates. What do we understand from this? We say capacitance is directly proportional to the area. It means that as you increase the area of the plate, more number of charges can be stored in it. So, capacitance is directly proportional to the area of the plate. Now, coming to the next one, capacitance is inversely proportional to the distance. This we have to discuss. I have written in points. Let me explain it to you. Please listen carefully. I have drawn the diagram here. This is plate A and this is plate B. It is connected to a battery, external battery. Plate A occurs positive charge, plate B occurs negative charge. A potential will be developed. Potential V is equal to ED, we all know. E is a constant. What is E? The electric field between the plates. Electric field, what will be the direction of electric field? From positive to negative. So, this electric field will be uniform in between the plates. So, E is a constant. So, what do we understand from this equation? The potential V is directly proportional to D, which is the distance between the two plates. So, keeping this in mind, we will do this discussion. First, we are going to discuss how capacitance is inversely proportional to the distance. First, let us take the distance D between the plates. Suppose D decreases. We will discuss both the cases. Supposing if we bring the two plates together, D is decreased, or if we move the plates farther apart from each other, that is D increases. Both cases we will discuss. If we bring the two plates together so that the distance between the two plates decreases, what will happen to the capacitance? If we just move the two plates apart from each other, away from each other, that is as distance D increases, what will happen to the capacitance of the capacitor? Both we will discuss, children. First, let us take the first case. If we decrease the distance between the two plates, D decreases. So, from this expression, what do you understand? When D decreases, V will also decrease. That is, V also decrease means the potential between the plates decreases, but the external it will be less than the external battery voltage. That is, plate voltage will be less than battery voltage. You have to understand, children, as we move the plates together, that is as we move the plates closer, the plate voltage will become lesser than the battery voltage. So, what will happen? Immediately it will try to equalize itself. Conservation of energy da. Immediately plate voltage battery voltage equal aga dhaan try pannum. So apdi equal agano appadinaka electrons must be transferred from the battery to the plate. Enga adhigama irukko anga irundhu kammiyana edathukku ponum. So electrons are transferred from battery to plate. So more number of charges will be stored in the plate. When the plate distance decrease பண்ணும்போது plate voltage decrease ஆகும். அப்ப more number of electrons will be stored in the plates. Upper Q increases. The charge that is stored in the plate will increase. So now we know the expression for capacitance of the capacitor. C is equal to Q by V. So C is directly proportional to Q. Upper Q increase agumbodhu C will also increase. So this you have to remember, children. When you bring, as D decreases, plate voltage will be less than battery voltage. Appa idha equalize பண்றதுக்காக என்ன ஆகும்? More number of electrons will be transferred from battery to plate. அப்ப பிளேட்ல நிறைய எலக்ட்ரான் ஸ்டோர் ஆகும், நிறைய சார்ஜஸ் ஸ்டோர் ஆகும். அப்ப Q increases. அப்ப Q increase ஆகும்போது ஆட்டோமேட்டிக்கா capacitance will also increase. Now just take the opposite case. If D increases, plate ரெண்டையும் ஒன்று தள்ளி எடுத்துட்டு போனோம்னா என்ன ஆகும்? D increasesனா D increase ஆகுனா voltage increase ஆகும். That is, in the plate, the voltage between the plates will be greater than the battery voltage. அப்ப என்ன ஆகும்? ஈக்குவலைஸ் பண்றதுக்காக electrons move from plate to battery. அப்ப பிளேட்ல இருக்கிற electrons battery போறதுனால plate will lose charge. அப்ப Q decreases. The charge of the plate decreases, Q decreases. Since C is directly proportional to Q, C also decreases. So what is the final conclusion? D decrease agna capacitance increase agudhu. D increase aachina capacitance decrease agudhu. That is why we say capacitance is inversely proportional to the distance. Next topic is, we are going to derive the expression for energy stored in a capacitor. So energy எப்போ ஸ்டோர் ஆகும்? when work is done. So that is according to work energy principle, whatever work is done will be stored in the body as energy. So இந்த இடத்துல what is the work done? So capacitor, we all know it consists of two parallel plates A and B. When you connect it to the external battery, what will happen? Electrons will be transferred from one plate to another plate. So this transferring, that is transferring of electrons from one plate to another, this work is done by the external battery. So the work done by the battery in moving the electrons from one plate to another plate will be stored as electrostatic potential energy according to work energy principle. So we are going to derive the expression for this work done. What is the work done? So initially we are going to find the very small work done in transferring a very small charge dq from the plate A to B. So charge dq is transferred from A to B, let us suppose, and the very small work done is dW. We all know the formula for work as W is equal to VQ. So here the very small work done dW is equal to VdQ, because the charge that is transferred is very small charge dq. So dW is equal to VdQ. Here, in order to find the total work done in transferring the total charge q from A to B, we have to integrate this equation on both sides. So integral dW is W. Here integral VdQ. We know the formula for C as C is equal to Q by V, then V is equal to Q by C. Substitute for this V as Q by C. So here C, which is the capacitance of the capacitor, it is a constant for a particular capacitor. So this constant you can take it outside the integral sign. So W is equal to 1 by C in veliyila eduthittu integral, we are going to find the total work done in storing a charge Q. So 0 to Q, Q dQ. We know the formula for integration. Integral x power n dx na eppadi integrate பண்ணுவீங்க? X power n plus 1 by n plus 1. இந்த இடத்துல n க்கு பதிலா இங்க 1 இருக்கு. So q power 1 plus 1 by 1 plus 1 is W is equal to 1 by C. You write it as such. This q power x power n plus 1 by n plus 1, இங்க 1 இருக்கிறதுனால q power 1 plus 1 by 1 plus 1 is q power 2 by 2. So after integration, the limits we have to put in the outer brackets 0 to q. Substitute the upper limit minus lower limit. Lower limit 0 ங்கிறனால விட்டுறலாம். Upper limit வந்து q க்கு பதிலா q தான். So W is equal to half. This 1 by 2 நான் வெளியில் எடுத்துட்டேன். 1 by 2 q squared by c உள்ள கொண்டு போயாச்சு. So W is equal to half q squared by c. So this is the work done in transferring charge q from one plate to another. In the work, according to work energy principle, this work will be stored as electrostatic potential energy. So according to work energy principle, this work done W will be stored as electrostatic potential energy. This is electrostatic potential energy. Normally potential energy we denote by the symbol capital U. Since it is electrostatic potential energy, you use a suffix small e here. So capital U to the base E is the work done. Work done we have derived as half q squared by C. But we know the formula for C is equal, C வந்து q by V ன்னு தெரியும். அப்ப q என்ன? CV. So denominator like V in the book it will come in multiplication. Q is equal to CV. So in the q squared வந்து CV, q க்கு CV in substitute பண்ணினா q square வந்து C square V square. So electrostatic potential energy UE is equal to half அப்படியே போட்டாச்சு. q க்கு பதிலா CV substitute பண்ணா C squared V squared by C. ஒரு C வந்து it will get cancelled. You will have electrostatic potential energy UE as half CV squared வரும். This is the expression, final expression. From this expression, what do we understand? We understand this electrostatic potential energy depends on two factors. One is the capacitance of the capacitor, another one is the voltage, square of the voltage. UE is directly proportional to V square. Now we are going to write it in another form because we are going to define energy density. அப்போ வந்து C க்கு வந்து we all, what is the capacitance of the parallel plate capacitor? We derived now for the expression for parallel plate capacitance of the parallel plate capacitor, C is equal to epsilon naught A by D. We all know the formula, V is equal to ED. So in the C is equal to epsilon naught A by D, V is equal to ED, in the equation substitute பண்ணினோம்னா UE, write it, UE is the electrostatic potential energy, is equal to half, write it as such. For C you substitute epsilon naught A by D into V squared க்கு வந்து E square D square னு வரும். V is equal to ED ங்கிறதுனால E square D square. அப்போ denominatorல இருக்கிற ஒரு D it will get cancelled. So you will have half epsilon naught A into இந்த A ஓட D combine பண்ணிக்கலாம். A into D into E squared. So, electrostatic potential energy UE is equal to half epsilon naught AD into E squared. What is this A? Area. What is this D? Distance. Area into distance is another volume. Volume of the, what is the volume of the space between the two plates? Upon this, we are going to, keeping this AD is volume. Expression for volume of the space in between the plates is AD, area into distance. Now let us define energy density. Energy density is denoted by the letter small u to the suffix E. Small u, electrostatic potential energy is capital U, energy density is small u suffix E. So, energy density energy per unit volume. So, already energy ku namak formula irukku, adu total electrostatic potential energy, idu per unit volume ku kandupidicha namakku energy density kadachidum. So, energy density small ue is equal to electrostatic potential energy ue divided by volume. So, ue ku inga substitute pannunga appadi in the expression half epsilon naught AD into E squared divided by volume is AD. So, AD will get cancelled. You will have the expression for energy density small ue is equal to half epsilon naught E squared. What do we conclude from this? This energy density depends only on the electric field existing between the plates, but it does not depend on the size of the plate. That is why இந்த எனர்ஜி கெப்பாசிட்டரை ஒரு ரெண்டு பேரலல் பிளேட்ஸை எடுத்து பேட்டரியில் கனெக்ட் பண்ணிட்டா it will acquire energy. Work will be done in transferring the charges from one plate to another plate. One plate will acquire positive charge, another plate will acquire negative charge, and this amount of energy density will be stored. Energy ஒரு per unit வால்யூமில் இவ்வளோ எனர்ஜி ஸ்டோர் ஆகிருக்கும் பிட்வீன் த பிளேட்ஸ். இந்த கெப்பாசிட்டரை கொண்டு போய் நம்ம ஏதாவது ஒரு சர்க்யூட்டில் கனெக்ட் பண்ணும்போது ஒர்க் எனர்ஜி பிரின்சிபல் பிரகாரம் இந்த அப்படியே இந்த எனர்ஜி it can be retrieved back. We can take it back. So, this is the formula for energy density. Energy density UE is equal to half epsilon naught E squared. With this we conclude this session, children. Thank you all.